Much better. Now we can see what we're actually working with here. So now that we've done a little bit of cleaning on this assembly, let's see what we can inspect before taking it apart. First off, there's not a whole ton of corrosion here, which is very reassuring. This OE black paint is kind of has held up not so bad. There's a little bit of surface corrosion right there that you can see. I mean, you know, mostly on the bottom half of the A-arms, but nothing too serious or structural. I think these can be wire wheeled and flap disked and rattle canned in black relatively easily. I did that to the sway bar a while back when I did my engine rebuild. This middle section had zero paint and was covered in rust because the master cylinder had been leaking. It was either I think the master cylinder had been leaking fluid down and it was landing here. And that also ate away the paint of the belly pan. But again, this is still pretty solid, and even though it's been taking a beating, it's still pretty nice. So I may just take all these parts and clean them up and rattle can them. Yeah, nothing too crazy here to see. Obviously, the bushings will be replaced, both at the front and at the rear of the A-arms. I also have these 4 sway bar bushings, brand new, sitting in a box. The main thing that I wanted to see on this assembly was the integrity of the aluminum cross member. And that's because I was concerned that over where the height adjustment screw had been bashed, this one is in good shape and could probably be reused. But over here where this one is bashed and bent to heck, I was afraid that this cast aluminum crossmember was potentially cracked or something, but other than that scuff there, it seems to be in pretty decent shape. So assuming I can cut out that screw and replace it with a new one, I think I should be able to reuse this unit quite confidently. So that was nice to see. Otherwise, can't really see any other issues here. Even the plating, the yellow cat plating on everything is holding up pretty well. So good to see. Also, these bad boys, the little caps, I mean, I kind of don't want to buy new ones. And these are very thick wall, mild steel, I think, because it's malleable and was able to bend. The hooks were able to bend from the impact, but the caps themselves are still in decent shape. So I'm sort of tempted to take these guys and since this hook is already partially peeled away from the torsion bar cap, I'm tempted to cut off these hooks and designing my own, maybe bending these or pressing these back into shape so they're a little bit straighter. Also, rattle canning these black again and potentially designing my own tow hooks with the same opening, possibly at like a 45-degree angle, so that I have better clearance to the ground and I can take these hooks and kind of sandwich them between the plate and this and the body. So Yeah, I think that's probably what I'm gonna do. And now it's time to go ahead and tear this down a little further to see what's going on inside. Whoa, sweet! I don't have to cut it out. Heck yeah, dude. Wow, this thing is jacked. I wonder if this is messed up though. Wow, I think it is because I can't. Right, might still be good. Sweet. Yeah, might be able to save it. Yeah, cool stuff. I gotta get these guys out of here somehow. Oh yeah. Ah. One. Oh, oh boy. Oh. All right. .745 inches. $19 millimeters. 19 millimeter front torsion bars. I'm gonna guess they're OE because of how old they are and how narrow they are. A couple more details on the aluminum cross member. Make sure that there aren't any cracks or obvious issues with this thing. Make sure that these little loops in the back aren't broken through. Otherwise, the cap, the torsion bar cap, and the height adjustment screw could fall out. I've seen people who repair these, but honestly, probably the best thing to do is probably to replace this if it's broken. Mine are not broken yet, so I think this one is still in decent shape, even though this side is a tiny bit yielded. I'll reassemble it and evaluate it. I think it'll be okay. Also, make sure these little hard posts that are pressed into the aluminum are still in good shape. This is a little hard steel pad that the adjustment screw will rest against. And obviously the steel screw is a much harder material than the aluminum, so you don't want this to be gone and to start to eat through the aluminum as it impacts this surface. So make sure this guy and this guy over here are still on, which they are here. So I think we're in the clear. Torsion bar, or anti-roll bar, which is also a torsion spring because it twists. Make sure this one is not, make sure it's not pitted or broken or cracked or anything obvious. As I mentioned before, I repainted mine a few years ago, so because it had this paint had worn off here, but painted it and it seems to be holding up fine. You can always give it another retouch if needed. So with those two parts in the clear as far as inspection goes, let's move on to our control arms and the torsion bars themselves. So let's talk about the torsion bars first. These guys, because they are a hardened spring steel that twists, it's very critical that they don't have any corrosion or any cracks in them, because if there is any type of cracking or chipping in the or hole in the material itself as they twist, you could have a creep failure where that little imperfection will start to grow into a crack, and it'll get bigger and bigger and bigger as the spring twists over road bumps and things like that, and eventually it could snap. So it's very important that you don't see any obvious cracks on the surface of these. Also, you're not even supposed to see any issues with the paint from spline to spline. And here we have some obvious corrosion here. Apparently what happens sometimes is as the bushings compress, and you can see in my, for example, in mine, the bushing is thinner on top than it is on the bottom due to the weight of the front end. Sitting on this bushing for 42 odd years or whatever. Apparently when this deflects enough, you can start having the torsion bar rub on the inside of one of the housings, and then the paint will come off, and then corrosion will start, etc., etc. So in summary, you can't have any paint issues or surface cracks or pits in these because they could fail. And apparently they just kind of wear out too after some time. You can see these are, I think these are my stock 19 millimeter ones, and they're kind of they're kind of pre-bent into a particular shape. So no doubt it's time to replace these. You can buy new ones. You can replace them with either the same size or upgrade to the turbo versions, which I believe are a little bit bigger diameter and have a slightly stiffer ride. There's also like the hollow ones that apparently are a little bit lighter than these while still maintaining the same spring rate. So we'll see. I think these are not very cheap, so I may have to save up a little bit to get a new pair of these. But let's move on to the control arms now. So obvious issues or obvious things to look for in the control arms are corrosion or things that are bent. Fortunately, nothing here seems to be bent out of shape. There is a tiny bit of it. I mean, if you look, there's a tiny bit of surface rust here and there, kind of like in those little spots right there. Nothing structural. So I may give these a quick scuff up and repaint with black paint just to give them extend their life a little bit more. You can buy new ones, but honestly, I don't know. These are in such great shape that I think it's worth it to just scuff them up and repaint. I'll probably use something like this. This is pretty awesome satin black paint that is fairly scratch resistant. It's definitely better than your like Rust-Oleum or some of those types of cheaper paints. So I'll use some of that. These bushings are obviously super tired, as I had mentioned before, so they need to come out. But before you start to disassemble this, there's a couple of things that you need to record so that you can replace the bushings and set these back to the correct angles to make it easier for them to mate back in your car. Because if these are straight, then you're going to have a lot of trouble putting these back on the car. So first thing you want to do is find a nice level surface. I could do it on the floor, but I'll just do it here on this table. Even though it looks kind of beat up, it's quite it's pretty level. Yeah, close enough. So what you're going to do here is you want this surface and this surface to be horizontal. So find something to put underneath the arm so that you get a level surface. Let's see if this, how about a little higher. How about right there? Close enough. So yeah, so this is level. This is level on this axis. And since this is almost perpendicular to this axis, we're going to go ahead and measure this side. See how flat that is. And it looks like it's pretty flat too. 0 degrees is straight up and down. So now that you have that leveled out, you want to go ahead and look at the orientation of these fittings so that you can put them back in the same orientation. And if you notice, this loop is facing outward, out towards the back of the car. This flange is facing inward towards the arm itself. I believe it's symmetric on both sides. And if you look at the front fitting, this kind of tapered end is facing towards the front, flange end towards the back of the arm. And then this fitting has these little ears, and they have kind of like sort of like built-in spacers or washers. The washers up here, as you can see, face up towards the body. So just keep that in mind. Take some pictures so that when you take them apart, you know exactly how to put them back together again. And now we just want to measure the angles of these relative to the arm. So now that we've established that this is flat and this is flat, let's now record these angles and see where this sits. So I'm going to sit this right there. And this sits at about, on my car, it sits at about 20 degrees relative to the rest of the arm. So I'm going to do that. I'm going to set this back to this angle when I put the new bushing on. 20 degrees relative to vertical. So 20 degrees that way. You can see here, this is the axis in here. On the front, I'm going to put it right there. And on my car, this is closer to 30, about 31, 32 degrees is where it likes to sit on my car. And then the other arm should obviously should give you the same angle. So double check both arms and record your angle settings for all 4 of the bushings so that you can reset these afterwards. And with that, I think we're ready to take these apart and pull some bushings off. One more detail that I almost missed. is on this this rear fitting. You can see that it has the loop has a big end and a small end, and the big end is going up towards the car. I didn't notice it until I started removing the bushings, but you can see this end is bigger than the one down there. Oh boy. So 150 degrees of heat did the trick for removing the bushings off of here and removing these rear sleeves from the bushing. The front ones decided to stay in, so I'm going to see if I can just press those out. They seem easy enough to do. Let's talk about suspension bushings for a little bit. So here are my old rubber front A-arm bushings that, as you can see, are pretty worn out. They're thicker in some areas, thinner in some areas. They're kind of cracking and stuff, but surprisingly, they're still compliant. It's almost like the rubber that was facing out, exposed to the air, was kind of dried and cracking, but the rubber that was held between faces or not exposed to the air is still kind of rubbery and pliable, as you know, feels still kind of new-ish. But
yeah, we're still going to replace them anyway because they're generally pretty beat up. Now, if you're looking for a ride identical to stock that prioritizes comfort, then you should probably replace them with the OE rubber bushings. They're quite soft. They won't squeak, and they'll minimize rattles and NVH issues. If you want something a little sportier, I believe there are variations of rubber bushings that are offered by other suppliers, such as Elephant Racing and some other suppliers that give you rubber bushings that are in a slightly harder compound to give you kind of a firmer ride and improved handling. The next step up is probably polyurethane bushings, such as these, which, depending on the brand and the hardness, will still have some compliance, but they'll be harder material. So naturally, as the material gets harder and harder, you're going to have a firmer ride and also transmit a little bit more vibration and noise and harshness into the cabin. So, and then a step up from here is probably, even harder bushings, maybe even solid Delrin nylon, things that you'll typically find in a race car. And then the top is obviously metal to metal hard joints, such as spherical bearings, uniballs, Heim joints, things of that nature. But we're not building a race car. What I am trying to do is build something that is still streetable, and it will be fairly comfortable on most street rides and highway rides, but at the same time will give me a slight step up in performance because I autocross the car. So because it's not a daily driver for me, I am willing to sacrifice a little bit of the ride quality in exchange for a little bit more firmer handling suspension. So for this build, I went with these bushings from Powerflex. And these guys, if you believe the marketing, they have a line called they have a bunch of very hard durometer bushings that obviously are more track car and race car oriented, but they also have this line called the Heritage Collection, which apparently strikes a good balance between comfort and performance, so that you can have kind of a sport plus type of a ride. So again, I'm kind of a noob in this area, so I'm willing to offer my car up as a guinea pig to test these things out and see how they do. I bought these from FCP Euro. This is where I bought the full set, and generally my decision was driven by the fact that FCP Euro offers them, and I've been buying a lot of parts from FCP Euro for a long time. I used to work for them for a couple of years, a few years back, and they generally sell really good parts and don't offer any subpar quality components for any cars. I used to buy a lot of Volvo parts from them back in the day, and my car has a lot of OE Porsche components that I've bought from them as well. So since I trust them, I decided, hey, let's give these guys a shot. So just to give you an idea of where we're at with the hardnesses of the bushings, the OE ones, the worn out OE ones, are in the general area of 62. They're in the 60s Shore A hardness. 65, 64, 60. So I'm going to give between 60, 65 Shore A for the front control arm bushings. Just for reference, here are a couple of the front sway bar ones, and they are are a tad harder. These are 67. This one is 72. Okay, so from like about 65 to 70 for the suspension one. I mean the torsion, the front A-arm ones. And for these guys, the PowerFlex ones, we've got, these are the ones that go on the front control arms, so they replace these. These are in the neighborhood of, these are a little on the harder side, 87. Yeah. So these are a little on the hard side. This is the top hat one, the one that goes at the top of the shock tower with the shocks coming in from underneath it. 75. Okay, so these are a little bit softer. Yeah, 79. They're definitely firm, but also have some compliance. This is the one that goes on your spring plate in the rear suspension. The rear torsion bar goes through here. So these guys are in the neighborhood of, yeah, they're a little on the harder side, 80. And then these guys are the ones, the inner pivot points on the rear trailing arms, 72. Okay, 79. Yeah. Again, upper 70s, low 80s. So we can see that obviously these are going to be significantly harder than these. From my understanding, and if you believe PowerFlex's marketing, all of their track and race car oriented bushings are in the 90 and up shore A durometer. So it sounds like, at least according to the numbers, maybe these are a kind of a good happy medium. And they're also gray. They're not purple or green or red or whatever. So these should have kind of an OE look when you look underneath the car. So that's kind of my thought process for how I went ahead and tested these bushings. I'm going to do some research on how to prevent these guys from squeaking, because that seems to be the biggest issue with polyurethane bushings, is that you put the included grease, and then after some time the grease will wash out, and then you'll get poly to metal contact, and that they'll squeak as the suspension moves through its range of motion. So I'm going to do a little bit of research on how to prevent that. And fortunately, since we're making this video, we know exactly how to go in and replace any components that become problematic in the future. So if any of these cause me any issues with squeaking or harshness or whatever, I can always go back, and you can always go back and replace each of the individual components with something that works. I don't know offhand if what the perfect recipe is for my suspension at the moment. It might be a combination. It might be all of the PowerFlex ones, or it might be a combination of OE rubber with polyurethane, or there might be some joints where it might be acceptable to have a hard, solid Heim joint or that kind of thing. But again, this is kind of how you do research. You try things and see what happens, and then depending on the results, you can go back and modify whatever still needs improvement. So that's what we're going to do about the bushings. And again, I'm not trying to steer you towards the direction of these bushings, or I'm just telling you that this is my thought process that I use for my car, and to take into account these factors when designing the suspension for your car, and don't just go straight with whatever the marketing tells you. Let's talk very briefly about tie rods. Here are my old tie rods. I believe these are actually, To be honest with you, I don't know if these are used on all of the long hood cars and the G-body cars, but they are used on the SC. This is the tie rod that came on my car, and as you can see, this connects the steering box to the spindle, so that when the steering box moves left or right, it moves the wheels left or right as well. And these are not great because they have this rubber isolator joint here in the middle that dampens some of the sensation between the wheels and the steering wheel. And here we have some turbo tie rods that I believe were OE on the Turbo 911s, and they have the same style of outer ball joint that connects to the spindle. However, on the inside, they have a ball and socket metal to metal joint here that just kind of swivels around, and there is no rubber isolator here on this side. So I should get a lot more steering feel through my hands in the steering wheel. And although so far with this 42-year-old set of steering arms, I had really awesome steering feel, and you can tell as you turn the wheel more and more and more what the tires are doing in terms of grip. But I want as much telepathic information coming through my hands as much as possible. So if I run over a piece of gum with my front tires, I want to know what flavor that gum is. If I run over some spare change on the road, I want to know what denomination those coins are. So all joking aside, it seems as though this is the upgrade to go with it that almost that most of the Porsche community regards as the right way to go. So that's what we're going to do here. I'm going to go ahead and use the turbo tie rods, and I'm going to trash these old ones, and decision done. After much thought, I've decided that we are going to rebuild the steering box. Since we're already in there and we have to replace the tie rods anyway, this job is not that much more difficult, so may as well take it apart and rebuild it while we're in there. But I'll go over its removal, rebuild in a different video. Let's talk about the front hubs, the brakes and bearings. So in my case, I'm not going to touch the brakes at all because I have already, prior to this, I have already put on brand new calipers. And while I was doing this, I went ahead and removed the rotor, the hub, and adjusted the bearings in the front, repacked everything with grease and put it all back together. And these front bearings generally they generally last a very long time because they are a conical roller bearing. So as clearances wear out and there's more gap space between the bearing and the race, you can actually go in and adjust the clearances and retighten things up over and over and over. So you can keep readjusting these as long as you keep them properly lubed up. You can keep readjusting them and get them nice and tight again. And I've done this job within the past maybe 4,000 or 5,000 miles or something. So I'm going to go ahead and leave those the way it is. But I did put together a written article on my blog of how this procedure is done, including the replacement of the front caliper and rotor. So I'll link that in the description of this video in case you are having issues or you simply want to go ahead and do this rebuild while you're in here, then you'll know how to do that. It just won't be covered in this video. I already spoke about how beat up these front torsion bars are, so I am going to go ahead and try to find a new set for the car, I'm going to try to go with the turbo spec. I don't know offhand what those sizes are, but they are a slightly bigger torsion bar front and rear that were used on the 911 turbos to give you a slightly firmer ride and cut down on body roll. So that's what we're going to do here.
Let's talk about some of the other suspension upgrades you can do in the front while you're in here. You can go with coilovers instead of the torsion springs and the shock. You can replace this assembly with some coilovers in here. However, if you do that, you need to reinforce the shock towers, because these shock towers were never designed to support the entire weight of the car. The springs do. So now you're getting into some welding and fab work in here to do that. I believe some people have gotten away with not reinforcing the front shock towers, and they reinforce the rear ones, but again, that's way out of the scope of this video, and more than likely to be on the safe side, and for durability you would need to do some welding in here to reinforce those shock towers. Another thing you can do is bigger torsion bars, as we had discussed earlier, and that's something that I will be doing with by swapping in some turbo spec torsion springs. You can also do a through the body sway bar. If you look under the front wheel well, there is this triangular depression here in the body that you can drill out. You can drill a big hole here and a little 3-bolt pattern here to put a straight anti-roll bar through this body all the way to the other side, and it sits in a gap between the body and the fuel tank. And then you put the sway bar in here. There's a plate here with I think with a bearing, and then you put these drop links that or you put this arm and then a drop link that goes down to wherever the sway bar mounts. Now on the AA arms, you will need to weld on some tabs so that the sway bar can connect to the A arms. And I believe this is kind of a variation of what Porsche used to do in on some of the old race cars. So if you want to know where a lot of the bases for these aftermarket components come from, you just need to look at all the old race cars, such as, you know, the 73, 74 RS and 934, 935, and all of the kind of 911 based race cars that have come out since then. Also, another thing you can do is you can lower the car, and in order to maintain your steering geometry, what a lot of people do is they take the spindle and they weld it, they have it re-welded a little bit higher so that the car sits in a lowered position, but it maintains all of the steering geometry. You can also lower the car normally with the adjuster springs in the back where the torsion bars are. However, now your tie rods won't be horizontal, they'll be at an angle, so you'll be dealing with some bump steer issues. So there are some bump steer kits that either add spacers to the steering box so that the steering box sits at a position such that the tie rods are a little closer to horizontal, or there are some kits that essentially have like a little rod and some spacers so that the ends of you can set the ends of your tie rods to be as horizontal as possible, and then connect down to the spindle itself. And like I said before, most of these things require welding or some kind of serious fab work. So if you want to go ahead and pay the bucks to do that, go ahead. And it's also very, very quickly to rack. It is very easy to rack up costs in the tens of thousands of dollars for
just one end of the suspension, where we haven't even started talking about the rear of the suspension yet. But for this car, as I mentioned before, we're not going to do any of that stuff. We're going to take a progressive approach and try to start with you know, the minimum cost investment possible, and then we'll start upgrading depending on how that revised suspension works, and we'll kind of go from there.